Okay, this is an introductory video into set theory. It is a mathematical language, so to speak, um, that was developed centuries ago by the old mathematician fuddy-duddies to organize and talk about numbers. Um, and I'm going to go over a few of the basics today. So here on the screen, you got a bunch of symbols. Um, no need to memorize that. You can reference it if you need to. Um, but I might refer to it so I have it on the screen. Okay. So when I say set, when I say a set, I want you to think of a box. Okay. Pretend like you've been working an office job for 10 years and all of a sudden they invented a robot that could do your job and now you're fired. Okay. So you have to clean out your desk and they give you a box and you put all of your belongings into that box, like pictures of your wife, pictures of your brothers and sisters, pictures of your parents, your favorite stapler, your favorite pens and pencils, and um, your mechanical keyboard, and your mouse that you bought, and all the things in your desk that are yours that you want to take home with you. You put it in the box and you carry it out in shame because you just got fired. Okay, think of that box with all that stuff in it as a set. Okay, and each thing that you put in that box is called an element. Okay, now the first thing we want to talk about is the cardinality of a set. A cardinality of a set. And I've been practicing here. Let's see, cardinality means size. Okay, in other words, how many elements. Okay. So this box that you filled up with your belongings and you're walking out to your car to put it in your trunk, how many things does it have in it? Does it have 18 things in it? Does it have three things in it? Does it have 112 things in it? That's the cardinality. That's the size. How many elements are in it? Okay. So that's fairly easy. Let's go over a few different notations that you're going to have. So let's see, how can I organize this? Let me pop another layer. And oops. Okay, hold on. Okay, I'll take all this off, but I know how to do this better next time. Okay, so cardinality is size. Okay, now there's a few different set notations. There's doing it in words. Okay, so if you were to, staying with my analogy, if you were to do state in words that box that's containing all your items from the desk, you would say it's B for box um, is all my belongings from desk. Okay, or B represents all my belongings from the desk. Okay, that's stating it in words. Okay, roster is the second one. There's three. Oh, hold on. Let me be smarter about this. New layer. Okay, so roster. Okay, roster is a list. Okay, so and it involves these curly brackets. So a roster, you put in like like all the stuff that I said, stapler, photos, charger, all the stuff you put in the box, you would list it. Okay, pens. Actually, you might want to list each individual pen, pencil. Uh, what else could be in there? Um, I don't know, what did I say? Keyboard. Okay, you just list each item that's in the box, and then you close it with the curly bracket. That's called roster. That's a list. Each individual element that's inside the box is listed out, separated by commas, left curly bracket, and at the end is a right curly bracket. Okay, that's roster. And the third and final notation, look at me, fancy mother trucker. Okay. The third and final notation is set notation. Okay. Whoa, whoa, whoa. Set notation. Okay. And set notation is if you have a huge amount of elements. Okay. If you just got like 10 things in your box, listing them is not a big deal. But if you have a situation where we're not talking about a box, we're talking about, I don't know, a boat with shipping containers on it, with literally like millions of products being shipped from China to the US. You're not going to want to list them all. You're going to want to have set notation that says this letter represents these items and this letter represents these items. Okay? So you have what's called set notation, and it's going to look like this. This is just an example. So be X such as, whatever you see this vertical line, you read that as such as. Okay? So X, such as X is an element. You see this like curved capital E. Okay, such as X is an element of, let's see, an element of box. Okay, and that way you can talk about the box as its own thing. So in case you have many boxes, or like many containers on a cargo ship or something like that, you can separate them and call each container a different letter because there's too many things to list. So set notation is the notation you would use if you have lots of elements, like way too many to list out, way too many to read, way too many to type. You're going to use set notation. Okay. So we've gone over cardinality, which is the size, and we've gone over the three different ways to talk about sets. You do it in words, roster, which is a list, and set notation. Now, let's talk about the difference between equal and equivalent. The difference between equal and equivalent. So get rid of that for now, get myself a new layer. So equal versus equivalent. Uh, Equivalent. So I'm still getting used to this pen. So equal, say I have a set where the elements in it are A, B, and C. And then I have, and remember, when I say the word set, I want you to think of a box. So this is a box with A, B, and C in it. And then there's another box, and that box has C, B, and A in it. Okay, these boxes, these sets are equal because what's in this box is exactly the same as what's in this box. It just happens that they are listed in a different order for whatever reason. This has an A in it, so does this. This has a B in it, so does this. This has a C in it, so does this. Okay, that's equal. Equivalent, let's say I have a box with A, B, and C in it again. And then let's say I have a box, and this box has X, Y, and Z in it. Okay, these boxes, these sets are not equal. However, this one has three elements in it, and this one also has three elements in it. That's equivalent. Equivalent is same number of elements. There's three things in this box, three things in this box. We call that equivalent. The only other option besides equal or equivalent, the third option is neither. Okay, so maybe if I were to add a D here, okay, well now this has four elements in it. This box has a D in it, and this box does not have a D in it. These are no longer equal, and this one has four elements, and this one has three elements, so they're not equivalent either. So we will call that neither. Okay, so either equal, equivalent, or neither. Those are your three options. Okay, so equivalent doesn't matter what's in the box. It only matters that they have the same number. All right, let's start with that information and we'll move on with more tomorrow.